You ever look at your phone bill and just wonder if you're getting the best deal? Or maybe you've wondered how forecasters can possibly predict the weather. Well, believe it or not, the answer to both questions lies in one of the simplest yet most powerful tools in all of math, the straight line. Let's dive in.
I know. It sounds like the beginning of a really weird joke, right? But just think about it for a second. Your phone, the weather, and crickets. What could possibly tie those things together?
And the answer, incredibly, is a simple straight line. Yeah, behind all the chaos of the world, there's often this really clear, linear relationship just waiting for us to find it. And that's exactly where linear equations come in. They help us cut through all the noise and see the basic patterns that, well, kind of run our world.
Okay, so before we can start using this awesome tool, we first have to understand how it actually works. So let's pop open our mathematical toolkit and take a look at the anatomy of a line. A linear equation is, you guessed it, an equation for a line. And the version you probably remember from school, the one that's going to be key for us today, is called the slope-intercept form.
And here it is, the star of our show, y equals mx plus b. I know, it looks super simple, but these four little letters are responsible for so much of how we make sense of things. Let's break down the two most important parts, b and m.
So first up, we've got b, which is the y-intercept. Now, the easiest way to think about B is just your starting point. If we're talking about a phone plan, B is that flat monthly fee you have to pay before you've even made a single call. It's where you begin. And next, we have M, the slope. So if B is your starting point, M is the path you take from there. It tells you the direction of your line and how steep it is. You know, a positive slope goes up, a negative one goes down. In our phone plan example, M is the cost for every minute you talk. So here's the key. B is where you start, and M tells you how you move. All right, so now that we've got the basics down, let's put this knowledge to the test. You are going to be surprised at how often this simple little equation shows up in the real world. Okay, this is where it gets really cool. That simple y equals mx plus b formula can model all sorts of real-world stuff. Take converting temperatures. The relationship between Celsius and Fahrenheit, it's perfectly linear. Or what about guessing someone's height from their shoe size? Turns out that's a linear relationship too. And my personal favorite is the crickets. You can actually estimate the temperature just by counting how fast they chirp. How cool is that?
So far, we've just been looking at one line at a time. But what happens when you have to choose between two different options, two different paths? Well, that's where systems of equations come into play.
And that brings us to something called a system of linear equations. It's really just a fancy way of saying we're looking at two or more lines at the exact same time. And the solution we're looking for, it's the single point where those lines cross. It's the one spot where both equations are true at the same time. So let's get back to our phone bill problem. Imagine you've got two choices. Plan A has a lower starting fee, that's its B value, but it costs more per minute, so it has a steeper slope, a bigger M. Plan B is the opposite. Higher flat fee, but a cheaper per minute rate. So, which one should you choose? Now, before we actually solve our phone bill problem, let's just take a quick step back and look at the big picture. When you put two lines on a graph, there are really only three things that can happen. They can cross at exactly one point. They can be parallel, meaning they never, ever cross. Or they can actually be the exact same line, just in disguise, overlapping everywhere. One, none, or infinite. That's it. Those are your only options. So the most common thing you'll see is one solution. In math speak, we call this a consistent system. It just means the lines have different slopes, they're going to cross at one specific point, and that point is your answer. Simple as that. Then you have the no solution situation. This is an inconsistent system. This happens when the lines have the exact same slope, but different starting points, different y-intercepts. Think of them like two parallel railroad tracks. They're going in the same direction, but they will never, ever meet. And finally, we have the really rare one, infinite solutions. We call this a dependent system. And it's when you think you have two different equations, but they're really just clever disguises for the exact same line. In this case, every single point on that line is a solution. Okay, now that we get the three possible outcomes, let's get back to our phone bill dilemma. We are looking for that one single crossover point where the cost of both plans is exactly the same. Let's find it. The logic here is actually pretty simple. We want to find out when the cost of Plan A
equals the cost of plan B. So what do? We literally just set their equations equal to each other. And once we've done that, it's just a bit of basic algebra to solve for x, which, remember, is our number of minutes. So, after all that, what is the magic number? After a little bit of algebra, we find that the two plans cost the exact same amount at 600 minutes.
And this is the key right here. At exactly 600 minutes of talk time, both plans will cost you precisely $64. So if you talk less than 600 minutes a month, Plan A with its lower monthly fee is the cheaper option. But if you talk more than that, Plan B and its lower per minute rate becomes the better deal. That's your decision point.
And really, this is what it's all about. Math isn't just a bunch of numbers on a page. It's a set of tools that help you make sense of the world. By understanding the simple power of a straight line, you can make smarter decisions, whether you're picking a phone plan, planning a budget, or even just figuring out the temperature from cricket chirps.
So I'll leave you with this question. Now that you have this toolkit, where else do you see these kinds of straight line relationships? How much you get paid versus the hours you work, the amount of gas left in your car versus how far you've driven. Now, of course, not everything in life is a perfect straight line. The world is messy. But the power of that simple line is absolutely everywhere once you know how to look for it.